Hello, Algebra 2. Up to now, we've been working with trig functions of acute angles, which are angles between 0 and 90 degrees, or 0 and pi over 2 radians. But today we're going to extend the definitions of the trig functions to include angles that aren't just acute. So let's go right into our notes. Here we're going to let theta be any angle in standard position. And if you remember what an angle in standard position looks like, let me quickly remind you. The vertex of the angle would be at the origin. The initial side would lie on the positive x-axis. And in this case, this is an arbitrary angle theta. So I'm going to draw my angle just to be in quadrant 2. And then we're going to define an arbitrary point xy to be a point that lies on the terminal side of theta. One thing to know about this point is that it cannot be the origin. And it's going to lie on the terminal side of theta. And so going back to my picture here, let me take this random point here. This would be x comma y, my origin, which is 0 comma 0. And before I define the 6 trig functions, just one last thing I need to define as well. I'm going to take the distance between my point xy and the origin. I'm going to call that r. And so we're going to find r by using the distance formula. This is the formula you want to use anytime you want to find the distance between 2 points. Just carefully plug in the values. And if you simplify it, you should get r is equal to square root of x squared plus y squared. Keep in mind, this is as far as you can simplify this expression. Don't try to do anything else. And so what we're going to do is we're going to define our 6 trig functions in terms of x, y, and r. So sine theta is going to be defined as the y coordinate over r. Cosine of theta would be x over r. Tangent of theta will be y over x. Cosecant of theta will be r over y, which is just the reciprocal of sine, right? Secant of theta will be r over x, which is just a reciprocal of cosine. And lastly, we have cotangent of theta, which is x over y, which is just the reciprocal of tangent. You want to make sure you memorize these. If you notice, we have a lot of fractions, and whenever you have a fraction, you need to make sure that you never have a 0 in the denominator. Otherwise, it would be undefined. So these definitions are defined in such a way, provided that none of the denominators will ever equal 0. Right? If you remember, if you divide anything by 0, that is nonsense. It's undefined. Okay? One thing I also want to mention briefly is that if you look at these 6 definitions and you're wondering where they came from, going back to our picture drawn here, the angle in standard position, let me form a right triangle so that one of the legs is on the x-axis. And if you look at the sides of this triangle here, the bottom leg would have length absolute value of x. The reason why I put an absolute value there is because the side length can never be negative. Because the y coordinate is positive, I can just call this to be y. Now, if you were to look at this angle right here, this acute angle, right, that the terminal side of the angle theta makes with the x-axis, if I were to find sine of that angle, and I did SOHCAHTOA, do you notice how sine of this angle right here would be opposite over hypotenuse, y over r? You notice I got that here? If I want to find cosine of theta, cosine of this angle here would just be adjacent of hypotenuse, which is absolute value of x over r. But here we drop the absolute value because cosine can take on positive or negative values, right, depending on what quadrant you're in. Tangent of theta, instead, let's look at tangent of this angle here, and that would be opposite of adjacent, which would be y over x. Again, we're dropping the absolute values. Anyways, let's look at a couple of examples here using these definitions. So a point on the terminal side of an angle theta is given. We're going to find the exact value of each of the 6 trig functions of theta using that definition that we defined earlier, okay? So for our first problem here, the point we're going to be looking at is 5 comma negative 12. Let me quickly just draw a picture for this so we can kind of understand what's going on here. So I'm going to first draw my vertex at the origin, my initial side on the positive x-axis. To figure out where your terminal side will be, you want to plot the point 5, negative 12. So let me just go 5 units to the right. Let me go down 12 units. This will be the point 5, negative 12. This is my angle theta. So here, because we don't know if theta is positive or negative, we can draw it however way we want. But in the end, it doesn't really matter because all we care about in this case is what quadrant it's in and what the point is on the terminal side of theta. Next thing you want to do is you want to find r, which again, r is defined to be the distance between the origin and the point. In this case, r will equal the square root of 5 squared plus negative 12 squared. All we're using is this formula right here. And if you carefully simplify this, you should end up with square root of 169. Again, r is to be 13. So I know r, I know my x coordinate, I know my y coordinate. At this point, we can find the 6 trig values of theta. So starting with sine theta we know is y over r, which in this case would just be negative 12 over 13. Cosine of theta is defined to be x over r, which in this case would be 5 over 13. Tangent of theta is defined to be y over x, which is negative 12 over 5. Cosecant of theta, which is r over y, is negative 13 over 12. Secant of theta, which is r over x, which is 13 over 5. And then lastly, we have cotangent of theta, which is x over y, which is negative 5 over 12. By the way, probably the quickest way to do this is if you find these 3, just take the reciprocals, right, and you can find these 3. But anyways, this is our very first example. Hopefully you get an idea of how we use the definition to find the 6 trig functions of theta, given a point on the terminal side of theta. So let me put number 2 right here. Let me call this point negative 1, negative 2. So as usual, when your video says your turn, I want you to pause the video, work this out on your own, and then press play when you're ready. So what I'm going to do is just draw a quick visual here, just so we can see what theta might look like. Once again, your angle is always in standard position. Negative 1, negative 2 would probably be somewhere right here in quadrant 3. I'm going to let theta in this case be negative, so it's going to go clockwise. And hopefully the first thing you did was you found r. So here's my x, here's my y. I know r is just the square root of x squared plus y squared. If you plug this in very carefully, you get negative 1 squared plus negative 2 squared. you get r is equal to square root of 5. So at this point, let's go right into it. Let's start with sine theta, which is defined to be y over r. In this case, it will be negative 2 over square root of 5. But we do need to rationalize this. Multiply the top and bottom by square root of 5, and you should end up with negative 2 rad 5 over 5. Now we're going to find cosine of theta, which is defined to be x over r. In this case, my x coordinate is negative 1. R is still square root of 5. You want to rationalize this out, you get negative rad 5 over 5. Tangent of theta, which is y over x. In this case, is just negative 2 over negative 1, or just 2. That's really nice. Let's look at the other three. Cosecant of theta, which is r over y, which is just negative root 5 over 2. Secant of theta, which is r over x, which we know is negative root 5 over 1, or just negative root 5. And then lastly, we're going to find cotangent of theta, which is x over y. This is just negative 1 over negative 2, which is 1 half. Hopefully you're able to do those correctly. If you made any mistakes, go back, look at what you did wrong, and make sure you understand how we're using these definitions here to find the 6 values of theta. We're going to look at one last example. This one's going to be a little bit different than the ones we looked at so far. Simply because this angle here, 0 radians or 0 degrees, doesn't lie in any quadrant, okay? But we'll still use the same definitions to find the 6 trig values of theta. So, as usual, I'm going to just draw this out. We're going to draw our vertex at the origin, our initial side on the positive x-axis. Now, because this angle is 0 degrees or 0 radians, the terminal side is on the same positive x-axis, right? They coincide. And so at this point, if you notice, we don't have a given point, right, on the terminal side. If you look at the previous two examples, we had 5, negative 12, right, as a point on the terminal side. For number 2, they gave us a point, negative 1, negative 2. But here, they didn't give us a point. Now, in this case, because they didn't give us a point, we could pick any point we want as long as it's on the terminal side. Because at the end of the day, it doesn't matter what point you pick. Any point on the terminal side will give you the exact same trig values. So I'm going to choose a point 1, 0. Choose the simplest point. Here, r is just 1. That's nice. The x coordinate is 1. The y coordinate is 0. So now let's find sine of 0, which we know is y over r. In this case, my y coordinate is 0. R is 1. I get 0. Cosine of 0 would be x over r, which is 1 over 1, or just 1. Tangent of 0, which we know is y over x. Here y is 0, x is 1. I get just 0. Those are your first three. Now let's look at cosecant of 0 radians, which we know is r over y, which is just r 1 over 0, which we know is undefined. And then we have secant of 0, which is r over x, which is 1 over 1. And then lastly, we have cotangent of 0, which is x over y, 1 over 0, which is undefined. Now, one thing to notice is if you had found these three, you could have just taken the reciprocals to get these three here, right? Because if sine of 0 is 0, if you take the reciprocal of 0, you get 1 over 0, right? Which gives me undefined. If you take the reciprocal of 1, you just get 1. If you take the reciprocal of 0, you also get something that's undefined. So really, at the end of the day, if you know sine, cosine, tangent really well, you can find cosecant, secant, and cotangent, right, using our reciprocal identities. But make sure you understand these definitions, okay? As a good practice, I would suggest you do this exact same example, right? We did it for 0 radians, but you should do it with pi over 2, pi, and 3 pi over 2 radians, right? This would be very good practice. And then you can check your answers with a textbook. If you remember, we call these quadrantal angles because the terminal side of these angles lie on the x-axis or the y-axis, right? None of these angles fall in any particular quadrant. So guys, this is the first part of section 6.4, which is trig functions of general angles. Make sure you understand these concepts before you move on to the next video.